Computer programming is a fundamental skill in computer science. No matter whether you want to work in software development, data science, robotics, and so on, you need programming skills. In this course, I will use JavaScript to teach, but what you can learn is more than JavaScript. Because apart from coding with JavaScript, I also teach you the concepts of programming and the practice and experience of programmers. In this course, I will teach you these things. These are 80% of the things covered in the first course in most CS degree programs. I won't cover the rest, but you will learn them eventually when you program more. I don't cover everything because that's how most people should learn computer science. I teach you the basics and you learn the rest by practicing. If I cover everything, this video will be hundreds of hours long and it's just a waste of our time and motivation. Though this course is an hour long, you should expect that it may take you a few hours because you need time to digest and do the practice problems I give you. Hope you can find this course useful and interesting. So let's start now. The first step to program is to install the tools. You will need to install two things which are VS Code and Node.js. If you want to use other IDEs, go ahead, but if you have no idea what these tools are, just follow me. Let's Google VS Code and then download it. Download it according to your machine and then follow the instructions. Though it looks simple, installing things may be one of the most tedious things in programming. Sometimes it takes me hours to set things up. If you have no troubles installing VS Code, you are lucky. Else, don't be mad. There will be more things that will make you mad later. Keep calm and Google your problem. You'll find it on Stack Overflow. If you get mad, take a deep breath and have a walk. After downloading VS Code, you can open a folder for storing your code, and then open VS Code and open your folder. Next, let's download Node.js. Go to the page and download the latest stable version. After downloading, reopen VS Code. If the terminal is not here, open it by clicking this. Type node-v to check whether Node.js is installed. If it is installed successfully, it should show you the version you have downloaded. If it doesn't, your download is not successful. Try re-downloading, checking your download options, rebooting your machine, and searching online. If everything is fine, the setup is finished. In the interface of VS Code, we have three parts. The left is the file list, the top is where we code, and below is the terminal. In the terminal, we can type commands to do many things, but in this tutorial, we mainly use it to ask the computer to execute the code we have written here and display the results here. The first program we write is a program that asks the computer to display something in the terminal. To do that, we open a file. Let's call it tutorial.js. You can make up the file name, but the extension needs to be .js, which stands for JavaScript. To let the computer display something, we use the function console.log. The console here is referring to the terminal. Log means record. Console.log is recording something on the terminal. If we want to record the number 24, we can write console.log bracket 24 semicolon. The semicolon is not required but highly recommended for indicating the end of the statement. This line of code is the first program you write that asks the computer to output the number 24 on the terminal. Let's press Ctrl S to save the file. To execute the program, we type node tutorial.js in the terminal. It tells the computer to execute the program in the file tutorial.js. After pressing enter, you can see the number 24 logged. Like what we do in math, we can declare variables to store values. For example, we can write let x equals to 2 to store the value 2 into the variable x. Then we can use the variable like this. We can write console.log x and then execute the program. When we use the same command, we don't need to type the command again. We can re-enter the command by pressing the up key. After that, we press enter and the value of the variable is logged in the terminal. We can change the value of x by reassigning x to 3 and then console.log it again. We don't need the word let as we are not declaring a new variable, but reassigning value. After executing it, we will see 2 and 3 are logged. Like math, if the variable does not change, it's called a constant. If we want a constant, we use the word const instead of let. If we declare a constant but change its value and execute it, we will see this error. Type error, assignment to constant variable. It means that there is an error because you reassign the value of a constant, which is not allowed. Constants are useful when you want to make sure the value is the same across the whole file, because if you accidentally change its value, you will see the error to remind you. There is a third word to use to declare a variable, which is var, but var is not that useful in my opinion, and we will talk about it later. Besides numbers, a variable can also store these things. Let's talk about strings and boolean first. Strings are a sequence of characters like the word hello. To represent a string, we need to quote it with a single or double quote like this. If we execute this program, we will see hello is printed. If you don't quote it, you will see reference error, hello is not defined. If you don't understand the error, you can search online like this. JavaScript, reference error is not defined. Remove the things unique to you because others may encounter the same error but using another string. It's usually enough, but if you want to make the result even more accurate, you can quote these words to make sure this phrase instead of separated words appears on the website. You can see it said you have this error because you are referencing a variable that does not exist or has not been initialized in the current scope. Why it says so is because you don't quote the word hello, making the compiler thinks hello is a variable name instead of a string. However, you haven't declared any variable called hello, so this error message is shown. The other type of variable is boolean. It is a data type that the value of it can only be true or false. For example, let x equals to true or let x equals to false. This data type will be very useful later, so please keep it in mind. Here I use x as the variable name for demonstration, but it is recommended to use meaningful names so that others and you will know what this variable is storing. But be aware that the variables cannot start with a number or contains any reserved word. For example, using the variable named let is prohibited, because the compilers wouldn't know whether you are declaring a variable or referring to a variable. Also, it needs to be one word. If you need to use more than one word, the common practice in JavaScript is to use camel case. This means we use capital letters for separating the words and use small letters for other characters. For example, if I want to declare a variable called my variable, I will declare like this, my variable, all small letters except the v. With numbers, we can instruct the computer to calculate things. For example, we can write console.log 3 plus 4, and then we will get 7. We can write let x equals to 3 and let y equals to x plus 3, console.log y, and we will get 6 because x is equals to 3 and 3 plus 3 equals to 6. We can also use the plus symbol, minus symbol, the asterisk for multiplication, and the slash for division. For example, if we write x equals to 2 plus 3 times 4 divided by 6, we will get 4 because we do multiplication and division first. 3 times 4 divided by 6 is 2, and 2 plus 2 is 4. To calculate exponential, we can use 2 asterisks. X equals to 3 asterisk 3, we will get 27 because 3 to the power 3 is 27. So let's have an exercise. For example, if we have the radius of a circle, how can we calculate its area in JavaScript? Please pause here and try before I show you the answer. In case you don't know how to calculate the area of a circle, I can tell you the formula is area equals to pi times radius square. So let's start calculating. So first we can define pi. For simplicity, we can let pi be 3.14. As we will not change the value of pi as a constant, and in JavaScript practice, we use capital letters for constants, so let's call it pi. If we have a constant with more than one word, we use an underscore to separate them. For example, we can call it pi approximate. With pi, we can calculate the area of a circle, so we can write let area equals to pi approximate times radius to the power 2, and then console.log the area. There is actually a built-in object method in JavaScript. It means something is actually defined for us already, and we can use it directly. And the value of pi is defined for use, so we can use math.pi instead of pi approximate here. And we can see that the value is more precise. One interesting thing is the percentage. We call it the modulus operator. What it calculates is the remainder when performing division. For example, 7 mod 3 is 1 because 7 divided by 3 is 2 with the remainder 1. Though we use it less frequently in daily tasks, we use the modulus operator widely in programming, so please don't forget it. To round down a decimal number to an integer, we use the function math.floor. For example, math.floor 3.5 is 3. If there is no problem, let's move on a practice problem. The question is like this. Given x seconds, please convert x into the format of h hours, m minutes, and s seconds. For example, if x equals to 4, 5, 6, 7 seconds, we can convert it into 1 hour, 16 minutes, and 7 seconds. The hint is you may use the modulus operator and math.floor function to do it. Please pause it here and try yourself, and I will give you the answer afterwards. If you are stuck, please search online before seeing my answer because it's an important skill to search online. So we can convert x into minutes and seconds first. We can think of how we convert it without programming first. If you remember what you have learned in primary school, we can do this by integer dividing x by 60. The quotient will be the minutes and the remainder will be seconds. To calculate this by coding, we can let seconds equals to x mod 60, which means the remainder of x divided by 60, and then the minutes will be the quotient of x divided by 60. However, if we divide it by 60 like this, we will get 76.116666 because it's not an integer division. We don't need the things after the decimal point, so to remove them we can use the function math.floor, and now we can get 76 minutes and 7 seconds. So to convert the minutes to hours, we perform similar steps. Let hours equals to minutes divided by 60, and then floor it. And the minutes is the remainder of minutes divided by 60. So we write minutes equals to minutes mod 60. After console.logging them, we can see the answer is 1 hour, 16 minutes, and 7 seconds, which is correct. I can also show you how I search for this problem online. We can search how to convert seconds to hours, minutes, and seconds in JavaScript. So for the first result, we can see these 2 lines which are relevant. We don't need the last 2 lines because it's used for adding a 0 in front of minutes and seconds if the minutes and seconds are single digits. But you can see this site only tells you how to convert to minutes but not hours, so we can move on to the other side, and on this site we can see the exact solution. You can see that he uses a function to wrap his code. Functions are a very important thing that you need to know, so let's talk about it now. So we have used this program to convert x to hours, minutes, and seconds. But what should we do if we need to convert 10 variables to this format? Let's say we have y equals to 5, 6, 7, 8 seconds. One way is to copy the code again like this. This method works, but the code is very bulky, and if you want to change something, you need to change all copies, which is very tedious. So what we can do is to define a function and call it when we need to use it. A function is something that we give some input, and it will do some process we want and may or may not output something. Unlike a mathematical function, a function in programming can also do some processes, like changing the values of variables. In programming, a mathematical function is called a pure function, while the other function can do other things apart from outputting a value. So let's declare a function. We need to give it a name, and let's call it second to hour, minute, second. What this function does is that we give it a total second, and it will convert it into hours, minutes, and seconds, and then print it out. So here, inside the parentheses, we need to say what we will give to the function. We will give it the total second, so let's put it in the parentheses. And we need to state what we want to do inside a pair of curly braces. What it does is just these lines of code, so let's cut it into the function. However, in this function, we use total seconds as input instead of x, so let's change x to total seconds. So this function is ready, let's try to call it. So we can use x to try it. We put x into the function and run it, and it works. Let's try y as well, and it works too. In the previous section, we talked about functions for number, and in this section, let's talk about functions for strings. We have added two numbers in the previous sections, but actually, we can add strings as well. Let's say x is hello and y is world. What happens if we console.log x plus y? The answer is hello world, so the strings are combined together if we add them, and it's called concatenation. So do you know what happens if we add a number with a string? JavaScript will convert the number to a string and then combine them. This is quite clever, as in most languages, it will report an error. So now I think the output is quite unclear, as there are three numbers, but we don't know which is referring to which. I would like it to print out the time in a format like hours, 1, minutes, 16, seconds, 7. So please pause here and try to print it like this by using concatenation, and after that I will tell you the answer. So to print it in this format, I will first print out the hours, and a space, followed by hours, and then a comma, and minutes, space, and then minutes, and then seconds, space, and finally seconds. Here my formatter makes it into 3 lines, but it's totally fine to leave it 1 line. We can check by running the code and it's perfect. If you think adding many variables is not convenient, we can use a template literal. Template literal is a string, but the string contains some variable. So we can use a template literal to represent this line of code. To use it, we do not use quotes, but a pair of backticks. And we use a $sign and a pair of curly braces to wrap the variables. So here we'll write hours, $sign curly braces hours, minutes, $sign, and so on. So I think the template literal looks better, as it is easy to write and read. So you can see it's just the whole string with 3 variables inside. So next I will tell you how to slice a string and output the length of a string. So slicing means choosing a part of the string. So let's define a string as hello world. So with slicing, I will show you how to select the substring hello and world. To select the world, we need to state that we need to select the string from which character. In programming, all indexes start from 0, so when we count things, we call the first thing the 0th thing. So in the string hello world, H is the 0th character, E is the first, and so on. We want a substring from W to the end, so we can count 0, 1, 2, 3, 4, 5, and W is the 6th character, as the 5th character is the space. So we can choose the substring world by writing x.slice6. So to choose the substring hello, we can first count the index. Hello is the substring from the 0th character to the 4th character. However, the upper bound of the slice function is exclusive, which means if we write 0th to the 4th, it does not count the 4th character. So to select 0 to the 4th character, we write slice 0, 5, and we can see hello is selected. So next I will tell you how to output the length of the string. It's very simple. We do that by writing a dot and a word length after the string, and it's finished. So next let's talk about things about the third data type Boolean. So it may look strange to have a data type that can only be true or false, but it's actually useful. So in programming, we always need to do something with conditions, and we can use the keywords if and else to do that. So let's have an example. For example, x equals to 2, and we want to print x is smaller than 3 if x is smaller than 3. To do that, we can write if x smaller than 3, curly braces, console.log x is smaller than 3. So we can see this line is printed. If we change x to 4, it will not be printed. So if we want to print x is equal to 3 if x is equal to 3, to do that we can write else if x equals to 3, console.log x is equal to 3. Else means otherwise. So else if x equals to 3 means if the first condition is not satisfied, we check if x is equal to 3. We use the double equal sign for conditions because single equal is used for assigning values to variables already. So we can test the function by changing x to 3 and we can see it works. So if we want to print x is greater than 3 if both conditions are not satisfied, to do that we use the keyword else. So here we can write else console.log x is greater than 3. And we check that if x equals to 4, this line is printed out. Apart from smaller, equal, and greater, we also have smaller or equal to, greater or equal to, and not equal to. When we want multiple conditions, we can use AND operators and OR operators. For example, if we need to print A if x is between 5 and 10, we can write if x is greater or equal to 5 and x is smaller or equal to 10. Console.log A. So if x is 4, nothing is printed. If x is 5, A is printed. If x is 7, A is printed. If x is 10, A is printed. If x is 11, nothing is printed. So for OR, if we need to print A if x is smaller or equal to 5, or x is greater or equal to 10, so guess what will happen? If x is 4, will A be printed? The answer is yes, because x is smaller or equal to 5. How about x is 6? Nothing happens because both conditions are not satisfied. How about x is 10? A is printed because the second condition is satisfied. So for AND, both conditions need to be satisfied. For OR, it returns true if one or two conditions are satisfied. So let's have some practice. Let's write a function to determine whether a number is even or not. Here I teach you the return statement in a function. So sometimes you don't want the function to print out the result. Instead, we want it to return a value for me to use. For example, I have a function is even. I don't want it to print out the result directly. What I want is like this. So if the function returns true, it will print this line, else it won't. So what should we do if we want this? We can write return something here. So for example, if we write return true, it means this function will always return true, so this line will always be executed. So let's do this question yourself. You can return true or false in different situations so that this function returns true if num is even and return false if num is odd. So now I will tell you the answer. To determine whether a number is odd or not, we can use the modulus operator. We can divide a number by 2. If the remainder is 0, the number is even. If the remainder is 1, it's odd. So we can write like this. If x mod 2 equals to 0, return true, else return false. So we can check it. If we input 2, it prints. If we input 1, it doesn't print. If we input 0, it prints. If we input -2, it prints. So to simplify the function, as a function can only return once, after returning, the rest of the code will not be executed. So we can remove the else here. So if it's satisfied, we return true. If it's not satisfied, we return false. To further simplify this function, we can actually return the condition directly. Why does it work? Because this statement returns a Boolean statement. If the statement is satisfied, it returns a true, and else it returns a false. We return this statement, we'll return the true or false value of this condition, which is what we want, so it works. So let's have another practice. Let's write a function to determine whether a number is positive. So let's write function is positive. Print positive if it returns true and else print negative. So please pause this video and try it yourself. So it's very simple to determine whether a number is positive or not. It's positive if the number is greater than 0 and else is not positive. So we can write return num greater than 0. Note that 0 is neither positive nor negative, so we use the greater operator here instead of greater or equal to. So sometimes you may want to write some descriptions about your code so that when the others read your code, they can understand them more easily. It's important for yourself as well because sometimes you will forget what you have written before. The description helps you recall what you have written before. So to write this description, we can write 2 slashes and then write your descriptions. For example, if you want to remind others, you use a greater sign because 0 is neither positive nor negative. We can write 2 slashes here, and then write 0 is neither positive nor negative. These descriptions are called comments, and comment will be ignored by the compiler so it won't affect the result of your program, but you can read the comments. You can also highlight the line of comments and then press Ctrl and / to comment them in VS Code. So next I will talk about arrays. To understand why an array is important, let's take a look at this problem. Let's say we have 10 classes of students. We have their exam scores and we want to calculate the mean of each class. Without using an array, what we can do is like this. Let's say we have 3 students in class A. We can call them A1, A2, and A3. Each has a score, so let's say A1 score equals to 80. A2 score equals to 70 and A3 score equals to 90. then we can write a function to calculate the mean. Let's call it mean, and it takes 3 parameters, which are the score of A1, A2, and A3. Then it returns A1 score plus A2 score plus A3 score divided by 3. Let's test the function by console.logging mean of them. So it calculates correctly. And let's do the same for class B. Let's say class B has 4 students. So we have B1 score, B2 score, B3 score, and B4 score. Then we may use the mean function to calculate the mean. However, we can't, as the mean function takes 3 parameters, but we need to pass in 4. So we need another function. Up to this stage, you should be able to imagine writing programs for all 10 classes will be tedious. It's only the case where there are 10 classes and each class has a few students. To simplify the process, we can use arrays. So what's an array? An array is a list of values. So we can use an array to store the scores of each student in a class. So let's declare an array and call it A scores. So we use a square bracket to represent an array, and we use commas to separate the values. So if we have 3 scores which are 80, 70, and 90, we can write square bracket 80, 70, and 90. So now we have declared an array, and here in the function, we no longer pass in 3 variables but an array. So this time we only need one function, as the function takes in an array that can have different lengths. In this function, we first calculate the sum of the array, and we can store it in a variable. Let's initiate it with 0. And after calculating the sum, we divide it by the number of students, which is the length of the array. As calculating the sum requires looping or higher order functions or recursion. And all these topics will be covered later in the course, so let's leave it here first. We can leave it here by commenting it first, and we'll cover looping soon after covering the other methods for array. To get the value of the array, we can get it like this. If we write console.log A score square bracket 1, we will print the values of the first element in the array. Please recall that in programming, we count things from 0, so the 0th value is 80, and the first value is 70. We can change the value of it also like this. Let's say A scores 2 equals to 75, then console.log A scores, and we can see the value of A scores changes. To add things to the array, we can use the push method. Let's say A score.push 60, and then console.log A scores. We can see 60 is appended to the array. To remove things, we can use the pop method. We can write A scores.pop, and then you can see the last element is removed. To learn more about other methods, you may search online or read these links. Next, I will talk about loops. Loops mean repeating. In the mean function, we need to calculate the sum. To calculate the sum, we need to add the first score to the second score, then add the resulting score to the third score, and then add the resulting score to the fourth score until the end of the array. So you can see that the adding step is repetitive, so we can use loops to do that. In JavaScript, there are 2 kinds of loop, which are for loops and while loops. And for loops, you have for loop, for in loop, for of loop, and for each function. So in this tutorial, let's talk about the while loop first, and then the basic for loop, and finally the for of loop. In the mean example, we are repeating the adding steps over an array, so we can use a loop. If we don't use loops, what we can do is like this. Sum equals to sum plus score array 0, sum equals to sum plus score array 1, and then repeat the process until the end of the array. Note that to add a variable by something, we can use the plus equals operator. So these lines actually can be written as sum plus equals score array 0. But still, this approach is long and we can't work with varying length arrays. To achieve it, we can use loops. I will first show you while loop because I think it's the easiest to understand. So we are repeating this step from 0 to score array.length minus 1. And we can let a variable I for counting, and it starts from 0. The process is repeating while I is smaller than score array.length, so we can write while bracket I smaller than score array.length. And in each iteration, we add the sum by the score array I, and after adding, we increment I by 1. A shorthand to increment I by 1 is I++. So let's explain what we are doing here. First, I equals to 0, and then while I is smaller than the length of score array, we increment sum by score array I, which is the first element 70, and then we increment I by 1, so I becomes 1. And then we repeat the step here, and we check whether I is smaller than the length, which is 3. I is 1, so it's smaller, and we do it again. We add sum by score array 1, and then increment I by 1, so I becomes 2. We repeat again and see whether I is smaller than 3. It's smaller, so we add the sum by score array 2, and then increment I by 1, so I becomes 3. We repeat and check whether I is smaller than 3. It isn't, so we exit the loop. And the sum is calculated correctly, and we return the mean. Let's run the program and you can see it works. It works for arrays of different lengths, and we can test it by adding a score to the array, and we can see it still works. So now let's talk about for loop. In my opinion, for loop is just a shorthand for a while loop of this structure. As this pattern appears frequently in a loop, we can combine these 3 lines in a line. Instead of these 3 lines, we can write for bracket let I equals to 0, semicolon, I smaller than score array.length, semicolon, I++. And that is, we declare the counter followed by the loop condition, followed by the changes at the end of each loop. And the last loop I will talk about is the for of loop. For of loops are useful when we are looping through arrays. As in this example, we are looping through an array. It's suitable for using a for of loop. Instead of using the index, we can directly loop with the value of the arrays. So we can write for let score of score array, and then increment sum by score. So you can see it's a bit cleaner. So if we are looping through an array, we can use for of loops. Please keep in mind that string can also be looped using a for of loop. You may need it in the future. In the previous sections, we have created arrays of numbers, but actually an array can also store values of other data types like string, boolean, and even arrays. We call an array of arrays a 2D array. 2D array is very useful in many cases, and one of the cases is to represent a 2D map. For example, let's say we have a rectangle map like this. Each cell is representing some area, and the value of it is representing whether that area is dangerous or not. To represent it, we can use a 2D array like this. Let map equals to square bracket true false false, comma, square bracket true true false. We can format it better by writing it like this. So guess how we can access the value of this cell. You may pause here to think about it, and I will give you the answer. So the answer is map square bracket 1 square bracket 2. Map square bracket 1 will return the first row, which is this row, and map 1 2 will return the second value of the first row, which is this value. Sometimes we work with coordinates when working with maps. In programming, we count from 0 and the y-coordinates increase downwards. So this is 0 0, this is 1 0, this is 2 0. And to get the value of coordinate xy, we get it by map yx, as is the yth row and the x column in the 2D array. We have loops for arrays and we have nested loops for multi-dimensional arrays. A multi-dimensional array is an array of arrays, and a nested loop is a loop in a loop. It may be complicated when you see it the first time, but it becomes simple after seeing it more. Let's see an example and guess what the output is and what the program is doing. Please pause it here to think about it and then I will tell you the answer. So in this program, we have an array of numbers called nums, and then we pass it to the unknown function. In the function, we have a nested for loop. For the first layer, we loop for I from 0 to array length minus 1. So in this case, we loop 4 times. The first time I is 0 and the last time I is 3. In each loop, we have another loop. In this loop, j loop from 0 to array length minus I minus 1. So in the first iteration, we have I equals to 0 and j loops 4 times from 0 to 3. In each iteration, if nums j is greater than nums j plus 1, we swap the two values in the array. So to determine what it is doing, we can dry run it with an example. So at the beginning, nums equals to array 3, 1, 6, 2, 5. In the first iteration, I equals to 0 and j loops from 0 to 3. If num0 is greater than num1, we swap the two. And in this case, num0 equals to 3 and is greater than nums1, which is 1. So we swap them and the array becomes 1, 3, 6, 2, 5. Next, j becomes 1 and we check whether nums1 is greater than nums2. Nums1 is 3 and is not greater than nums2, which is 6, so we do nothing. And after that, j becomes 2 and we can see nums2 is 6, which is greater than nums3, which is 2. So we swap them and the array becomes 1, 3, 2, 6, 5. j becomes 3 and we see nums3 equals to 6 as greater than nums4, which is 5. So we swap them and the array becomes 1, 3, 2, 5, 6 and j becomes 4. As j is not smaller than 4, so we terminate the loop and I becomes 1. We repeat the step, but this time j only loops from 0 to 2 instead of 3. We see num0 equals to 1 is not greater than nums1, which is 3. We do nothing and j becomes 1. We see nums1 equals to 3 is greater than nums2, which is 2. So we swap them and the array becomes 1, 2, 3, 5, 6 and j becomes 2. Let's stop it here as the remaining steps are the same. If you can't understand it, you may watch this part again. So you can see that the resulting array is 1, 2, 3, 5, 6 and it is a sorted version of the original array. This algorithm is called bubble sort and is the simplest sorting algorithm. If you are puzzled why this function can sort an array, I will explain it to you now. If we repeatedly swap the values if the left number is greater than the right number, the largest number will go to the rightmost of the array. For example, for the array 3, 1, 6, 2, 5, we swap 3 and 1 as 3 is greater than 1. It becomes 1, 3, 6, 2, 5. We don't swap 3 and 6 as 3 is smaller than 6. We swap 6 and 2 as 6 is greater than 2. And after performing these steps, the array becomes 1, 3, 2, 5, 6. And you can see that the greatest number, which is 6, goes to the rightmost position. And the code for this step is for let j equals to 0, semicolon j smaller than array.length minus 1, semicolon j plus plus. If array j is greater than array j plus 1, swap array j and array j plus 1. To sort the array, you can repeat this step once to put the second largest element in the second last position. The code is the same, but this time we do not need to handle the last element because the last element of the array is in the right position already. So we minus 1 here. and the array will be sorted if we repeat this step array.length -1 times. So we can use our loop to repeat this step for array.length -1 times. After each iteration, we reduce one comparison, as we do not need to handle the rightmost element, and the code becomes the one you see before. To digest the knowledge, let's have a simple exercise. Given this map, please print all the coordinates of the true cell in the map. For example, given this 2D array, we print these three coordinates 0, 0, 0, 1, and 1, 1, as these three cells are true. Please pause here and I will tell you the answer later. So the answer is simple. To traverse a 2D array, we use a nested loop. As I didn't teach you how to use for of loop to get the index, I use a basic for loops instead of for of loops here. The first layer iterates through the rows and the second layer iterates through the columns. If that cell returns true, console.log the coordinates. We can write if map yx instead of if map yx equals to true, as map yx itself is true. We write if true instead of if true equals to true, so why don't we write if map yx? So let's run the program and we can see that it works. Sometimes you would like to use keys instead of indexes to search for elements of an array. For example, let's say we have 10 student scores. We can store them in an array, but what if we don't remember which student is the first and which is the second? We can't retrieve the score without knowing the order. To retrieve the value by other things like name or ID instead of index, we can use objects to store the key value pairs. For example, if John has 10 marks and Mary has 50 marks, you can write curly braces, John : 10, Mary : 50. To retrieve the value, we can write score square bracket, quote John or Mary, and we can retrieve the score of them. To update the object, we can update it by score square bracket, quote Tom equals to 30, and we can print it out and see that Tom is added to the object. We cannot have two values represented by the same key, so if we write scores square bracket John equals to 60, we will update the score instead of adding a new value. Let's have a practice. This practice is to implement Caesar cipher. First, let's talk about what Caesar cipher is. In 100 BC, a Roman general, Julius Caesar, wants to send secret messages to his generals so that his generals can read them but others cannot. He thought of a simple method, which is shifting the characters by 3 positions. A will become D, B will become E, and for X, we will count back to A, Y will be B, and Z will be C. So the message hello world will become KHOORZRUOG, as H shifting 3 will be K, and so on. So let's write a function that can convert a message to its encrypted form. For simplicity, let's assume the message only contains lowercase letters. And after finishing it, you can try to write a function that can encrypt the message with different keys. In other words, not only shifting by 3 positions, and we can determine how many positions we want to shift. Please pause it here and I will tell you the answer. So the first function is easy. We can create an object which maps the character to the encrypted characters like this. Object A:D and so on. After that, we can loop through the message string. For each character in the string, we use the object to encrypt the character and append it to the return string. We can test it and we can see it works. For variant keys, we can do similar things, but this time we don't hard-code the map. We can create a map by looping, and there will be different ways of implementing it. It's totally fine to have different approaches, and I'm only providing you my answer. First, I create an array storing all lowercase letters in alphabetical order. After that, I create an empty object and loop through the letters. In each iteration, I add the key value pair to the object. The key is the letter I am looping, and the value is the index of the letter plus key and then mod the length of characters, which is 26. Let's say key is 1. For character A, the index is 0, and the value is the 0 plus 1 mod 26, which is 1 of the array. So the encrypted value is B. And for Z, the index is 25, and the value is 25 plus 1 mod 26, which is 0, which is referring to the letter A. And the rest of the codes are the same, so let's test it by different keys and they should work. In JavaScript, function is also a data type. We can store functions in variables and we can pass functions to functions. These functions are called higher order functions. In this tutorial, I want to introduce two higher order functions which are map and filter. Map is simple. Let's say we have an array 1, 2, 3, 4, 5. What can I do if I want to increase all value by 1? One way is to use a loop. We loop through the array and then for each value we increase it by 1 like this. The other way is to use the map function. In a map function, we pass a function to it to ask the computer to apply the function to all elements in the array. In this case, we want to apply a function that adds 1 to all numbers in the array. So let's declare that function first. Let's call it add1. And what it does is simple. It takes a num and returns num plus 1. And we can run the program and it works. As it may be a bit bulky to define a function like this, we can use arrow functions to simplify the code. Apart from using the word function to define a function, we can define it using the parameter bracket, followed by an arrow like this. If a function does nothing apart from returning a value, we call it a pure function if you remember what I said before. As it's a pure function, we can further simplify the function by removing the curly braces and writing the return value directly like this. When you read others' code, you may see someone declare other functions using arrow functions as well. So let's use that way to write the function add1 to all. You can see that add1 to all is also a pure function, so we can directly write this bracket and then an arrow and then the things it returns. This is the add1 to all function, and we can give it a name by writing const add1 to all equals. So now everything can be written in one line, and this is the power of functional programming. Let's talk about the filter function as well. In the filter function, we want to return an array that contains only the elements which satisfy some condition. For example, let's say we have an array nums which has 4 numbers which are -1, 4, -2, and 2. We can use the filter function to return only the positive number. To do that, we can pass in a function that returns a boolean indicating whether the condition is satisfied. We can use the isPositive function we wrote before, but let's simplify it using the arrow function. It can be written as num arrow num greater than 0. So to filter the positive numbers, we can write nums.filter, this function, and you can see only the positive numbers are left. So let's talk about recursion. Recursion is quite a hard topic. I remember I took some time to be comfortable with it, but it's really amazing in my opinion. I think it works like magic when I see it for the first time. Basically, it's a function calling itself. It's hard to explain, so let's see an example. Calculating factorial should be the simplest recursion example. Before I start, I need to make sure you know what factorial is. So the factorial of 6 equals 6 times 5 times 4 times 3 times 2 times 1. And we only have a factorial of positive integers or 0. Search online if you don't know what factorial is, but let's start implementing it now. So you should know that calculating factorial is very easy using loops. We just loop from 1 to x and then multiply all the things, but this time I want to show you another approach. So we should know that the factorial of 0 is 1, and the factorial of x is equal to x times the factorial of x minus 1. So first we can write down these two pieces of information in a function. If x equals to 0, return 1, and otherwise, return x times the factorial of x minus 1. And after writing this, the program is finished. I'm not kidding, let's run the code. We can see factorial 0 is 1, factorial 1 is 1, factorial 2 is 2, factorial 3 is 6, factorial 4 is 24, and factorial 5 is 120. Perfect, isn't it like magic? So if we find a problem that can be solved by the function itself and the function will reduce to a base case, we can use recursion. What it means is that as we know the recurrence x factorial equals x times the factorial of x minus 1, this function can be solved by the function itself. And when it calls itself, x is reduced by 1, and as x is a positive integer, it will eventually become 0, and we know that 0 factorial is 1, so we can define it as the base case, and after knowing this, we can write the base case and recurrence directly. So let's see a harder example. Let's say we have a sorted array R, and we need to know whether a number num exists in R. So first we can do a sequential search for sure. We iterate through an array and check whether the element exists. It works, but it's not efficient. In this course, I won't talk anything about efficiency as this is another topic, but you may still think whether there are ways to solve this problem faster, especially when the array is very long. Please pause here if you want to think, and I will tell you the answer now. As the array is sorted, we can first check the middle number. If num is smaller than the middle number, you know the number either exists in the first half of the array or does not exist. So we can repeat the step on the first half of the array. If you are sensitive, you may be able to smell the smell of recursion, as we are solving the same problem with a smaller array. If the middle number equals to num, you know num exists, so we can return true. Else, which means num is greater than the middle number. We know num either exists in the second half of the array or does not exist. So we know the answer equals searching nums in the second half of the array. Using this method, we search for fewer times, and this method is called binary search. Let's turn this logic into a program. In the previous step, we have already defined the recurrence and the base case of the found case. So we only need to define the base case for the not found case. The base case is simple, it's when the array is empty, and in this case, num must be not found. So the code is just the same as this logic. If array length equals to 0, return false. Otherwise, we check the middle number. The middle number is the number and the position, which is the floor of the array length divided by 2. If the middle number is equal to num, it is found, so return true. If the middle number is smaller than n, we do not need to consider the first half, so we can search for the second half. So the result equals to binary search of the second array, which is array slice from mid plus 1. Otherwise, search on the first half and is equal to binary search of the first array, which is array slice from 0 to mid. Let's test the program. we can declare a sorted array, let's say -1, 0, 3, 5, and 9. Then we can make up some numbers to test. The test case should contain different cases so that the testing is more comprehensive. For example, we can have num smaller than the first number in the array, num is found, num is not found, num is greater than the last number. Without thinking, let's test all from -2 to 10. We can write a simple for loop to test it. In these two examples, it's better to implement them using loops instead of recursion. As exercise, you can use loops to implement them. However, in some problems, it's much simpler to implement in recursion, and it may be necessary for the algorithm course, so it's important to learn recursion as well. So when we declare a variable using the keyword let, the variable is scoped by a block. A block is usually characterized by a pair of curly braces. For example, if we have if true, let y equals 1, and then console.log y, we will get a reference error, because the variable declared with let can only be accessed in the block. In this case, the block is the code in the if statement. If we want to use y outside the if statement, we can use the keyword var. The variables declared by the keyword var are scoped to the function so that the whole function can access the variable. If we declare a variable with the same name in a smaller scope, there will be shadowing. In this example, if we declare y again in the if statement, the y in the if block will refer to the y declared in the if block, while the y outside the if block refer to the y which have a larger scope. Let's say we have an array 1, 2, 3. We can reassign the value of it like this. And we can mutate the value of it like this. Though they have the same value, these two behaviors are different. The former is called reassignment, and the latter is called a mutation. A reassignment will create another array, and the variable will refer to the new array instead of the original array. While in a mutation, the variable is referring to the same array, but the value of the array is changed. To show you why they are different, we can have this example. In this example, we let y equals to x and then reassign x to another array. We can see that x will be 2, 2, 3 while y is 1, 2, 3. However, if we mutate x instead of reassigning it like this, both x and y will become 2, 2, 3. It's because in both cases, x and y are referring to the same array originally. If we make x refer to another array, they will have different values. If we change the value of the array, both x and y will change as they are referring to the same array. It may be tricky, especially when you are passing arrays to functions. For example, in this case, you may want to change x, but x will not be changed because we reassign r but not x. This function will mutate x because r and x are referring to the same array and we change the value of r. If you want to avoid this confusion, you may return an array in the function instead of mutating it in the function like this.